Alright, in this video we're going to look at Unit 6, Objective 2, the intermediate value theorem. Intermediate value theorem, we'll start by saying, is one of the few things that you're allowed to abbreviate when you are talking about it on the AP exam. You can call it IVT. The readers are going to understand what you're talking about, so you don't actually have to write out intermediate value theorem. So what the intermediate value theorem says is that if f is continuous on the closed interval a to b, then there exists a value c on the open interval a to b, such that f of c falls between f of a and f of b. So what that means in just normal everyday language is that for any continuous function, you're guaranteed to hit every y value between the y values of the endpoints of the function. So if we just take an endpoint here, take an endpoint here, and we connect them in any way that we can think of, as long as it's continuous, we are guaranteeing that every y value from this y value right here to this y value up here, every y value here is going to be hit on your function somewhere. Now, it doesn't say that all the y values are going to stay in between those two, right? Over here, we go above this y values or this endpoint's y value. But what we're just saying is if I'm going to connect two endpoints with a continuous function, I'm going to hit every single y value in between those two. Now, one thing that the intermediate value theorem does not tell us is where that value exists. So they're not going to say, let's say that this was like 7 and this was 9. The intermediate value theorem doesn't say at x equals 2, the y value is going to be 8. All we know is that the y value somewhere is going to be 8, because 8 is going to be between 7 and 9 on the y values. So it doesn't tell us where, it just tells us that it happens. So our AP is often is going to ask us to verify that a certain y value exists on a function on a certain interval. That's where we're going to end up seeing this on free response type questions. And this is how we're going to know we're using IVT. Later on, we're going to learn the mean value theorem, and that's going to ask about derivatives. So if they ever say, does a y value exist, we know we're going to be thinking about intermediate value theorem. So our AP justification is going to say, because f of x is continuous on the closed interval a to b, and f of a equals h, and f of b equals k, intermediate value theorem guarantees a value c on the closed interval a to b such that f of c equals j. Now, where this is going to come into play, how this is going to look a little bit nicer is that value j is going to be the one that they're asking you to show it exists. So up here they're saying a y value. They'll say, does the y value j have to happen? This value must be between h and k, right? So it's going to be between this y value of this endpoint and the y value of this endpoint, if IVT is going to work. And if we don't say that f of x is continuous, we are not going to earn any credit. So we have to have this sentence word for word memorized for our AP justification. So let's look at what this might look like. So example 1, let f of x be a continuous function on the closed interval -2 to 5. Certain values of f of x are shown in the table below. At how many values of x is f of x guaranteed to be -3? Justify your answer. So this isn't saying exactly how many times does it happen. It's saying what's the minimum number of times does it happen. So how many times is it guaranteed to happen? So f has to be, f of x has to be -3. So if we think about the intermediate value theorem, they're saying if I have two endpoints, I have to hit every y value in between those. So if we look at this first little interval here, I'm starting at -2. So that's a y value of -2. And I'm going to -5. Well, if I'm going to go from -2 to -5 with a continuous function, I have to hit somewhere in there -3. So somewhere between x equals -2 and x equals 0, the y value has to be -3. So there's going to be at least once. If we're going from -5 to 0, on my y values. I know I'm going to have to hit somewhere in there is going to be a negative 3 as well, so there's going to be a second time. And then from 0, we know we go up to 3. Now, could this function drop below negative 3 and hit it a couple more times before it bounces back up to positive 3? It could, but it's not guaranteed to. So this is guaranteed to happen 2 times. And then our justification, we'll just justify the first one, and then the wording would be the same. But we would say, since f of x is continuous on, and we're just going to take this first one. So we're going in between negative 2 and 0. So continuous on the closed interval negative 2 to 0. And we know that's true because we're continuous all the way from negative 2 to 5. So we have to be continuous on 2 to 0. So since f of x is continuous on the interval negative 2 to 0, and one of my endpoints, f of negative 2, is equal to negative 2, and my other one, my other endpoint, f of 0, equals negative 5, IVT guarantees a value on the interval negative 2 to 0. So between 2 and 0, not counting negative 2 and 0. So some value on this interval such that f of x is equal to negative 3. So again, we don't know where it happens in between negative 2 and 0, but we know that it's going to happen at least once. It could happen more, but we know it has to happen at least one time. So there's our justification. Since f of x is continuous on negative 2 to 0, and f of negative 2 equals negative 2, and f of 0 equals 5, IVT guarantees a value on negative 2 to 2 such that f of x equals negative 3. We would say something similar from 0 to 3, using our endpoint y values as negative 5 and 0 to get the other justification. But for now, we'll just call it quits on this video, and we'll see you in the next one.